In our DevOps tool chain, this is what we are going to do, guys. We're going to talk about Git, GitHub, Jenkins, Docker, Ansible, Kubernetes, AWS. The order is not exactly the same, all right? But these are the tools we are trying to cover up. Kubernetes and AWS is what will get you a job. That's what everybody is looking for now. All right. Let's start with Git. That's the simplest one. We should be able to get through it in a day. Git. We'll try to understand it in a non-technical context. Git has nothing to do with technology. It's a very simple thing which can be used by, let's say, a writer. Let's say you are a writer. You write nice stories. What's your regular process of writing a story? What would you do? Let's say you are writing a love letter. Simple. That's much better. Let's see. How do you start? My dear XYZ. No, it's not good. Scratch it and throw it out. Next paper. Next. No. That is draft 1, version 1. Let's do next. Come on, my dear XYZ. You started next sentence. I like you very much. This applies to both, male and female. All right. Anybody writing the letter. Then scratch it. No, this is not really good. Scratch it, throw it out. Version 2. Next. Alright, so you have at least 10, 20, 30 versions by the time we give it to him or her. Alright. So how do you manage all these versions? Let's say at 4th version, let's say you're writing version 4, V4 kind of thing. You realize version 2 was good. That sentence, the opening sentence in version 2 was good. Now, where do I get version 2? You start, browsing through all the papers that you throw out. Now, that's really painful if you have 20 versions. There are 20 papers lying down over there. You don't know which one it is, and you're already frustrated. Come on, I can't write a love letter. I've seen so many movies. Everybody writes a love letter. People do it in their school. Kids write love letters. We can't do it. So the versioning is a problem. You can write nice stories the same way. Which means when you're writing anything, or when is it software or a simple story or anything, you always have versions because that's how we improve things. We fix things, we improve things. Fixing is, let's say you made a spelling mistake, you strike it off, you write the correct one. Improving it, okay, let me change the sentence itself. That's improvement. Now these things always come one after the other. Now each time you do it, it's a version. Now if you are doing it for a big novel, let's say you are writing a nice novel, right? You have a lot of chapters in it. Each character has to be developed. So you have a lot of work to do. Now it's difficult to keep track of when you did what. Let's say you are writing this novel over a period of a month. Just now we have seen, even for 1 hour, love letter, you have so much problem. 1 month, too many characters, a complex novel, it's a big problem. So version, or controlling the version, or tracking the versions has always been a problem. Not just software. Even before software was invented, people used to write letters or novels or stories, right? You need to keep a draft. They used to call it drafts. Draft 1, draft 2, draft 3, draft 4, final draft, ultimate draft, super draft kind of thing. So version controlling or drafting is a common process that we need. That's how we develop stuff, not just software. So you have version 1, version 2, version 3, version 4 of your own story. This is called version tracking or version control. Now, how do we do it? Let's say you are writing a nice story on a Word document. All right, today you wrote something, then tomorrow you are modifying it. What would you normally do? You open the same file and you modify it and you save it again with the name, right? Your old things are lost because you are modifying the same file. All right? Day 3, you wrote some more. You added some additional things, additional paragraphs, right? Same file, you stored it again. Nice, all right? 4th day, you realize I want day 2 things, but you already edited it, removed it. You don't have that. And being a writer, you always get a new idea. You can't get back the same idea. All the creative things, the problem is you can't get exactly the same thing. That's the problem with being creative. So how does this guy get day 2 story on day 4? I'm just talking 4 days. What's the option? What's your solution? Save every day with a different name. Day 1, day 2. My story hyphen day 1.txt. My story hyphen day 2.txt. My story hyphen day 3. That's simple way. Alright? Now at any day you have day n. You want to get back day 2 details. You open that file. Right? Perfect. Now you have about 10, 20 files like that. Right? At any given point, your latest file is your latest story. Right? If somebody asks you, you can browse through all that stuff and get back anything that you wrote on that day and send it across. Now assume this is happening with 5 friends. You are 5 friends, all of you together writing a story which has 5 characters in it. Each one of you is developing a character. All these characters should come together like the Ram Gopal Varma movie. Right? That's what he does. So they should come together at the end and it should make sense and it should make money. Now, what's your process? How would you do that? So friend, let's say writer 1, writer 2, writer 3, writer 4, writer 5, let's say, beside, all right? Writer 1 writes it on his laptop. Everybody is remotely, everybody is sitting at their home. They need a nice ambience to write stories, right? They have that set up in their home. So everybody is writing. So one person, writer 1 writes the story. Writer 2 is also writing. Now at some point they need to map, right? So let's say you are writer 1, right? What's your name? Suman. Let's say Suman is our writer 1. Suman wrote everything. He thinks that this is the nicest story that exists in the world. It cannot be any better than this. All right? Now, he sends it to how many? 4. There are 5-member team. All right? He sent it to 4. How does he send it? Email. He has that my story hyphen final version .doc. He opened his Gmail and sent it across. CC all the 4 members. Yeah, see how beautifully I written my story. Please respond. His friends saw the story. What's your name? Sampath said, this is crap. What's your name? Samya said, okay, it can be better. Another third person said, it's excellent. Fourth person said, he edited already everything. Okay, this is a better version. You come back, all the 4 came back to you. And those files were named. You guys were really systematic. What they sent it like? Suman, right? Suman story final version hyphen v1 rewrote .doc. Everybody sent that file. Now how many files you have on your laptop? You have your 4 files. Everybody sent a rewritten file. All right. Now this happened with 5 members. Everybody is sending to everybody. So how many files each member has now on their laptop? No. You have 4 rewritten ones, your own one. You have 5. All right. Sampath is also sending you the same thing. Sampath has 5. All Sampath files should exist with you also, right? You have to know what other people are saying about Sampath. You have to agree on that one, right? Let's say, because you are discussing it. Sampath said, no, this is crap. And you don't agree with it. Why you are saying stuff? Let me show let me see your story. Let me see what others are saying about your story. Means everybody has everybody's files. So we have 5 members, each member 5 files. How many total files? Somewhere around it. So you are managing 30 files. That's only 4th day. You written only draft 1. Now assume this whole writing process goes on for a month. How many files you are going to have? You guys are really fierce, means good writers. Writing everything, drafting it, throwing it out, rewriting it, really kind of all this wonderful. Who is the best writer now? Now, any good writers now? Current writers' names, no? No, anyone. Telugu, Hindi, English, anybody. Yeah. I say you are that guy. You are collaborating with 5 others and you guys are writing together a story. Now, how many files we have at the end of 1 month? And now, because you are a writer, you don't just write one story. You are probably writing 2, 3 at a time. So you have at least 100 files to track. And now, let's say one of you has a Windows laptop, other one has Mac. Now, all this time you are sending .doc, the Mac will not open the .doc. What happens now? That guy says, no, I can't open any of your files. Now, your solution is install Windows or buy a new laptop. No, we can't buy a new laptop. We don't want to buy a new laptop. I like Mac. So you see the problem? The problem is tracking versions is always a problem. Even in software or even in simple story writing. So people have evolved, especially in software, this happened over a period of time. How do we track all the software? This is all programming, code, right? It's just code. You're writing a Java program, it's code. It's written in a pseudo English kind of thing. You write a Python code, it's code. You write C, you write Fortran, you write basic programming language, or you write COBOL, any programming language, Node.js, JavaScript, anything is programming. And when people write it together, it needs to be tracked. And usually, a software development team, how many programmers would there be? Let's say Amazon itself, the interface you are looking at, right? How many programmers do you think are working on that interface? 2, 3? You sure?
No, sir. What program is
At least 200, 300,000 people are working on it. That's the reason they're able to keep up with so many changes. And you see, all these e-commerce sites, whenever some new feature comes in one website, on the very next day, you will see the same feature on other websites. Flipkart, Amazon. Amazon guy releases a new feature, you see it on the second day. And they're always monitoring, there are always developers who are ready to start working immediately on a new feature. WhatsApp, let's say. How many people are working on WhatsApp? Probably a lot of people. Now, when a lot of people are working, you have a version control problem. Everybody is working on their laptop. So they are writing a code on some kind of notepad in their laptop. Now, when 100 people start to write code on their laptops, and it is expected to work together. For example, on Amazon, you have an interface, home page, all right? This is where all the listing happens. Let's say a group of 10 developers are developing it. Then you have a payment gateway where it interacts with payment systems. A payment gateway has a lot of options it will give you. You want to pay with credit card, debit card, UPI, or wallet, all that kind of stuff. Then each of these credit cards has to be integrated with Visa card, MasterCard, all that stuff. Then there are a lot of gateways, ICICI gateway, HDFC gateway, Deutsche Bank gateway, Citibank gateway, all that stuff. So all these things is very complex. Now let's say you bought it accidentally something, you don't want to keep it, you want to return it back. Now cash on delivery, direct paid or non-direct paid, why you are doing all this stuff? You have to do a SMS or you have to get an email, all that stuff. So there are 100 people working here. Now the problem here is these things should work together as a system. So it's not just 100 people we are talking 300 people's code should work together. Now you have a serious problem. Even a small glitch or unnoticed thing will shut down your website. And let's say not shut down. Let's say one of these things, UPI payment is not working for 1 hour on Amazon. What's the approximate loss? We're talking only one feature, UPI payment, which means you cannot pay using your Google Pay or Phone Pay. For 1 hour it was not working on Amazon.in. All right. How much do you think is the loss? They say it goes into millions, crores. You think they'll be okay with it? But can they do anything? Can they fire their developers? They can't keep firing their developers. It's not the problem with the developer. Bloody, you can't track it. Everybody is writing it. It's not my problem. I written my code well. It is not able to integrate with your system. That's not my problem. If we keep firing everybody, everybody gets fired. You won't have a developer. Which means we need a system which can track all this stuff. That's your version control system. And in this case, it's distributed. You're distributed across developers. The version control. It's not happening on your laptop. A lot of people are writing from a lot of places. All the remote teams. You're sitting here in Hyderabad, your friend, your teammate is sitting in Bangalore, somebody else is sitting in New York. You're all working together writing the code. All right? So the version control system, there were earlier version control systems also before Git, but now Git is more popular because of its features. SPNs were the earlier ones. Then there are other things. Let's look at Git directly. Git, let's say this thing. How it does its version controlling is, let's say you are writing something, a notepad. Right? Your file, myfile.txt. You wrote line 1 in it. Alright? When you wrote line 1, use Git and say you commit it. Means you store this version, that's what you are telling Git. What Git does is, it has a directory called .git. Inside this, it will store your file. And it says version 1. So your whole file is stored here. Then you changed or you added another line, line 2. Alright? You added one more line, line 3. Again you said git commit. It says version 2. It's also stored. Version 1 is also stored. Then you went ahead, removed line 2. Alright? Then you said git commit again. It stores version 3. So at any point of time, it has all the versions that you want to store. When you want to store something, you say store it. Now the way Git does is, it does it in 3 different what we call areas. So there is one thing called working area. Then there is an index area. Then there is a tree. This is your final tree or local repo. This folder structure, all these calls are usually called repositories. A repository, like a tar file. A repository. So let's see what is happening here again. You are in a directory. Let's say cd/temp my code is the directory you are working under. In this directory, you have a file myfile.txt. Alright? In the same directory, there is a .git directory. You wrote something. Now you want this version to be preserved by Git. Now the way you say it is git add the file name myfile.txt. When you say add, it stores here. Currently you are in working directory. You are working. When you say git add, it brings it here. It's just a name, myfile.txt. Like it puts a pointer. Means you probably want to store it permanently. You added it. After adding, you are sure, okay, I want to permanently store it. Then you say git commit. When you say commit, it compresses the file using a compression algorithm. So if this file is about 10 KB, your compressed file is probably even below 1 KB or something. And it stores it here in a repository, in what we call a block object. This is all internals of Git. We don't have to really worry why it does it or how it does it, but what we have to know is your file is stored in the repository. So under Git directory. So you have a working area, then an index area, and then a local repo. Where all this thing is happening? On the local system itself. We're not really talking about a remote system. We're not really talking about sending it to your friend at. Means within your system. When we are writing your love letter, you started throwing everything away. Even that we want to track. We don't want to throw things randomly. We want to keep it like a nice stack. If you want version 2 of your letter, you can pull it very simple. Means even when you are doing it alone, you still want to track it. And where that one person tracking is happening, within your local system, in your house. You're not collaborating with anybody yet. You're writing it alone on your own. Even then, you want to track everything. So Git will work on local system first. So we are only talking about local system at this point. We're not talking about distributed system yet. So what happens is, anytime when you install a Git software, you have these two commands. You start working in a given directory. You edit your file just like you edit any file. All right. After you're done editing, when you reach the stage where, okay, I want to save this version. It looks like this is an important point where I should save all these things. Then you say git add. When you say git add, your Git will make a note of your addition. Okay, this version we have to store. Let's keep it here. It is not compressing yet. Means you haven't confirmed it yet. You are simply saying, okay, add it, keep it away, kind of thing. So it kept it away, that file. All right, and then you confirmed it using git commit. These are the two commands that come one after the other usually. Git add the file name, git commit. Now with a commit, you give a message. This is my first file, let's say, any message. So git add and git commit. What is happening here is, inside the .git directory, here itself we are talking. So cd/temp/mycode. This all happening in the same directory wherever you are working. All right, nowhere else. In the directory, you have your files. In the same directory, there is another directory called .git directory. The .git directory has all the internal things happening. You don't really touch it. Right? It just stays here. If it is removed, this whole thing is removed. So what we are doing is, you work on your file, you're okay, then you add it to your index. Now adding it to index essentially means, okay, be ready to compress it. That's what you are saying. It's like a yellow light in your traffic signal. All right, get ready kind of stuff. So index will have all the files that you are about to commit. So index can have my file 2, my file 3, my file 4, like this. You are working on 4 different files as an individual, developer. Then every time you reach a point where you said, okay, this file is ready, this code is ready, you are adding it, but you haven't compressed it. After you added all the files, let's say you did 4 additions. Git add my file 2, my file 3, my file 4, like this. So you have 4 files here. Then you said, okay, go ahead, git commit with a message all 4 files. Then it compresses all the 4 files together into a single block object and then stores it here. Very simple. So what you have is a working directory, an index, and a local directory. Now these things are usually called trees for some reason. So you have a working tree, an index tree, and a local repo tree. Now the common commands here are these things. Git has about 10 commands. That's all you need in Git. These are the commands I'm going to list out. Git init, git add, git commit, git checkout, we will talk about it, git push, git pull, git clone, git log, git diff. That's it. I think git diff is also not necessary. That's all you need in Git. That's the very reason why it's so popular. It's simple. You all agree simple things are more popular? If the usage is easy, why is Windows so popular? Usage is easy. If it is too complicated, like Linux, nobody cares about. We don't really need complicated products. It has to be simple. Why your smartphone is so popular? It's easy. Ease of use is really an important feature in software development. You can't make a really complex product and assume that users will use it. Nobody cares how good your project is or product is if it is not usable. Now the reason for Git's popularity is uses. All that you need is 10 commands, that's all. You can do all the wonderful tracking. These are the only commands you need. We're going to talk about those things. We're done with 2, add and commit. What add will do? It will add your file to index. Then commit will compress it, put it into your local repository. Now let's say git checkout. So here you are, this is a tree. Alright? Now when we say tree, you're basically talking about a list of compressed files or what we call commits. So commit 1 is here, commit 2 is here, commit 3 is here. That's all commits, right? Each commit is a blob, a block object, which means a compressed list of files at that point of time, isn't it? Now, let's say you want to start diverging from here. You written your code, my file 1.txt, or instead of txt, let's call it .java. You are a Java programmer, or you are a Python programmer. You written your my file 1.py, my file 2.py, all your Python code. All right, you are editing this code, you are compressing and committing to your local repository. Now, when you are using, talking about these things, it's important to use these keywords. You are actually storing it here. You can call it storage. You are storing it here. You can call it always storing. That also is correct. But if you say commit it, it makes more sense to anybody who is listening. All right. So you commit all your changes to the tree local repository, local repo. Now let's say you have my file 1, my file 2, my file 3 like this. You committed somewhere here, commit 4. From this point, you thought you will add a new file, my file 4.py, but you are not really sure whether you are going to keep it or not. It's just more like an experiment you are trying to do. Maybe the code will work or maybe it will not work. But if it does not work, it's going to break my original code. So I want to slightly, means I need this code, but the new addition that I am making is an experimental one. I may want to keep it or I may want to completely remove it. If I want to remove it, the removal process should be easy. It should not break my original thing. Then what you do is, This is your main tree, you branch out. So you create a branch of your main tree. This is all trees, branches, forests, all that stuff. All right. Somebody, nature lover, has written it. This is Linus Torvald has written Git, the guy who created Linux. All right. So you are branching out. Now, when you're branching out, you are on a new branch. Let's say now you added a new file using your touch command. Then you edited that file. All right. Now again the same stuff. You did a git add. When you did a git add, it stored it here. Then when you git commit, it stores it on a branch. So your commit here is on a branch. It's not on the main branch. And the way you branch out is this. Git checkout -b, the branch name, let's say feature 1. That's a branch name. All the code related to feature 1, you are doing it on branch 1. If something goes wrong, this main branch, it's usually called, is not affected at all. You can remove all the code. Git will allow you to do that. So you are on the main branch or you are on the branch, one of the branches. Everything is called a branch. So this is in a local repository, you have a main branch, or it's sometimes called master branch. A master branch was the original name. Recently, Microsoft had changed the master branch to main branch in their repository. They don't want to use this names, master slave thing. A slave word is little derogatory in Western countries. Recently, that black things happened, right? What's that name? Floyd, somebody, right? So, as a response to that thing, they changed master slave nomenclature into main thing. So, Git or GitHub is owned by Microsoft. I'll tell you about that thing. So, this is called master earlier, now it's called main branch. So, you may find both names. Master is old, main is new. They don't want to use the master slave nomenclature anyway, but it's still there in most of the softwares. We'll come across that one later. So you have a main branch or master branch, and then you have sub branches. Now this branching can go as deep as you want. You can branch out again from here. You can branch out again from here, like this. Every time you branch out, you just do a checkout. Now when you do a checkout, what essentially happening is, it takes this commit, git, it puts it into here. So at any point of time, it will say git checkout this branch. You are pulling the code at that point of time, the committed code, the compressed code, into your working area. So it's not necessary that you depend on your current directory status. Let's say you written draft 1, all right? You stored it, you committed it to the local repository. Then you went ahead and you written branch 2. You checked out into branch 2, you written a lot of stuff. Now you want to get back to main branch and start writing. All that you do is check out this commit. Check out this commit or check out this branch. That's what you are doing. So you're basically pulling lots of versions of your code. Any version is basically a whole compressed file you have. Now this is an important point. Git can store only regular text. It cannot track anything that is formatted or anything. Means Excel sheet, can it track? No. Word documents, can it track? No. PDF files, can it track? No. Images, can it track? No. All that it can track is simple text. That is called source code. Source code is text. It's not any format. How is it different? How a notepad is different from a Word document? You have Notepad on your Windows laptop, right? You also have a Word document. You also have a PDF. What's the difference among these three? Coding. What else? When you open a Notepad, you open a Notepad. When you open a Word document, you go to MS Office, open a Word document. A PDF is usually, if you have a PDF writer, you can edit a PDF file. But if you look at Notepad versus Word document has a software which actually gives you the facilities to format it, make it bold, unbold it, all that stuff. Now, when you change that code, let's say you formatted it, there is a metadata associated with your regular text. Somewhere in the Word document, it says that this word has to be displayed in bold. It's there somewhere. That's a simple, somebody written the code that says, okay, store this data. If this guy is doing select all and clicking on bold, somewhere it's written that this text has to be stored in bold. That feature is provided by the software, the Word document, or the MS Office, Microsoft Word. So there is a software which is actually changing your code. Notepad, no such thing happens. It does not do anything at all. It's pure, simple ASCII text. Whatever you type in from your keyboard, it gets stored. Now, Git can track only unmodified or regular text only. Anything that has metadata associated with it, anything that has changed, it will not track. Means it cannot track Word documents. It cannot track Excel sheets. It cannot track PDF files. No, it does not know how to track it. It can only track regular text files. So your Python files or Java files, whatever it is, it's pure text. You typed it and it's available there. That's it. It only compresses it and stores it. That's all it does. It's a very simple stuff. So source code is pure text. That's all it can store. All right. So what you have is, and again coming back here, you have checkout means you usually move across the branches wherever you want to work and then work on that particular branch. Now once you finished your working, let's say you've done your working here. So you have a couple of commits here. All right. Now let's say you're happy with it. Okay. Looks like everything okay. Now I want to put this code back on my main. Till this time, what you said is, what you thought is, maybe this will work or may not. I'm not really sure. You work for a couple of days, then you realize, this is coming out nice, so I can put it to main. So what you do is, you merge. That is git merge. Git merge branch 1 into branch 2, in this case, main branch. So what happens here is, it takes all the commits, it puts it into this thing. So you have a nice main branch with all the commits. Or you can compress all the commits into a single commit and merge it with main branch, whatever you want. That's an optional thing. Don't worry about it right now. So the point here is, if you have a branch, the branch can be merged with any other branch. You're saying branch 1, branch 2. In this case, I given main. You can say B2 also. So what the developer is doing essentially is writing the code. She is storing it into the branch local repository and they're merging it with local branches. The main branch is the main branch usually. So whenever you are in Git, if you want to see which branch you are at, this is your command. Git branch list all the branches in verbose mode. This is a command that will tell you all the branches in your local repository. This is something that you will need from time to time. You're working, then you went out for a coffee, and you came back, you don't remember which branch you're working on. You just list out all the branches, it will tell you what is your current branch you're working on. We'll just touch upon the remote part and then we'll stop. We'll get into workshop. Now this whole thing is happening locally. Now let's get back to our 5 friends writing the story. Now you want to send this whole code, nice code, to your friend. But you guys are 5, which means you don't really want each person to send it to everybody else. It's not like, it's like everybody shooting arrows at everybody else. All of you will die kind of thing. So instead, can we put all our code into something like a common G drive folder? That makes sense. Why do we send an email? Let's not send an email. Everybody put your code into G drive. If anybody needs it, we'll pull it from there. That makes more sense. And the same thing here. This is local. And for one developer we are talking. Now if you have 10, 20, 30 developers, instead of everybody sending their code to others, we can set up a common, what we call a remote repository. This is all local. This is your local repository working on your laptop. You set up a remote repository and everybody can push their code to remote. That's your command. Git push remote branch, git push remote, and on that branch name. That's what logically makes sense, right? The remote repository is also a repository, which means it is also going to have a main branch or master branch. It is also going to have all the branches, B1, B2, B3, anything, just like that. Now when you're done, you push the code, git push to the remote, this one, onto the branch, one of these branches. Now let's say the remote is called origin. If we are naming this remote as origin, and on the origin you have a main branch. So what would be your push command? Git push to this remote. The name of the remote is origin, and on that main or master. So this is the most popular command you say. Git push origin master or main. Origin is the name of your remote. Now because it's remote, which means it exists on the internet, isn't it? You are sitting on your laptop, you are saying something is remote, it exists on internet or on some other system. Now in this case, internet, which means the origin is essentially a URL. You are sending somewhere, there is a repository like a G drive. G drive is a URL, right? Send it over there. Over there, there is a branch called master. Put my code in here. So what you are pushing is your local repository, not your working directory. So what you see is not necessarily going to your remote. What you have committed is going. So this thing, so what normally we do, we finished everything, we did a git add, which will add here, and then git commit, everything gets committed, then we do a git push. So now your nice beautiful code is here. What the rest of the members should do, they should take this code and continue their work. So your friend is sitting here somewhere in New York. What she will do a git pull of your new code into her repository. So git pull again from origin, very good, from the branch master. That's it. So she has all the code that you have pushed. So anybody can push it to the repository, anybody can pull it. So this is the remote repository. And the most popular remote repository nowadays is github.com, owned by Microsoft. So GitHub is essentially a website or a server that stores all your code in the form of Git. So you have a local repository, you have a remote repository. Everybody pushes their code to the remote repository, pulls the code from the repository. That's all Git is about. So you have the 10 commands. Let's look at Git. Now, at the very beginning, you wanted this .git directory, right? You get it using git init. You are telling the operating system, initialize this directory as a git directory, which means it creates this whole structure and it creates the .git directory in it. So you have git init, that will make your git directory, then git add, it will add the files to the index, git commit, anything on the index will be compressed and put into the local repository. Then you want to git branch out, so git checkout and work on something else. You are done with everything, then git merge it, merge branch 2 into main. Then you commit everything again, git add and git commit. Then you do a git push origin main on that origin. You push your code, now you want the code from your partners. So you git pull origin main. That's it. Those are the commands you need.
So do we have notes about this one? Actually, we have
This whole thing? No.
discussion contents is there in this one.
Notes is not there. You have video streamed. It will be given to you the URL. Creating text is really time consuming. Telling it is much faster. So even if I create this whole thing, I can't put everything into text kind of thing. It's difficult, time consuming.
Yeah. By writing the running notes, we are missing something.
Yeah, we have stream, so you have a recorded version of it. You can repeat it as many times as you want.
We had some writing problem in this. Only you are using one marker now.
Mm-hmm.
In video manner, it's somewhat difficult to understand.
In video? Yeah, this board, yeah, and a board on the video is difficult to, yeah. Here it's much better. I got the same complaint from our online guys. So, yeah. Video, yeah. We're trying to change it into an electronic board. Maybe that will help a little bit. But I don't think so. I think the problem is with my writing, not the board.
Writing is no problem, sir. But if you use multiple colors, that is better.
Only black is visible on the video, black and blue. If I am using green and red, they're not at all visible. So maybe I'll try to use these two from tomorrow onwards.
That problem may be rectified by electronic board that they are having.
Maybe, yeah, I think probably, yeah, probably next session onwards you will have it. I'll give you the videos then again. Any questions here? This is really important. This is all visual. The problem with Git is you have to visualize where you are working. You can't really see that. Everything is again, same black screen that you're working on. This whole Git thing is about visuals. You have to visualize your working directory. When you say git add, you have to visualize that you are adding it to index. And when you say git commit, you have to visualize that you are committing everything to local repository. You are compressing it and storing it into a very small file. Now remember, why Git is so efficient is, it does not try to store big files. All that it is handling is text. Let's say you have a code of 10 million lines. What is 10 million? 1 crore. You have 1 crore lines. All right? How much space do you think it's going to take? You are committing everything. All right? Let's try to segregate why Git can actually do this stuff, right? A 100 lines notepad, how much space it consumes? Hardly. 100 MB? No, not at all. A letter consumes 1 byte. That's how your programming is designed. If you are in an electronics or electrical background, A, B, C, D, these ASCII characters, they consume 1 byte. 1 byte is pretty small one. So if you have a file of 100 lines, each line about 100 words, it would not take you more than 1 KB. 1 KB is 100 lines you are talking. You can actually try it. Open a notepad and put some 100 lines and write 1 KB. 1 KB is nothing. Until we reach a MB size, it's nothing. The MB is 1024 KBs, which means if you have about 1,00,000 lines of code, 1,00,000 lines of code, even then your file size will not reach 1 MB. So these commit blobs are not really of big size. It's just pure lines of code. That's it. It is not dealing with big images or photographs or videos. No. So when you are committing, you are actually committing a lot of same versions. But because it deals only with text, it is able to do it. Alright, so when you visualize, you have to visualize that my whole code is compressed, zipped, tarred and done and into a blob. That's your commit. A commit will have a code. It's called hashtag, the Twitter ones. Each commit has a hashtag. A hashtag is a big ID kind of thing. All right? Each commit is represented by a number. All right? So this main branch is basically a big list of your compressed files. It's a group of blobs. All those things will be in this. It's just a bunch of tarred, zipped files. That's all it is. But all the complexity is hidden by these simple commands. It's just like a car. When you drive it, you feel it really nice. You don't understand the complexity, isn't it? We don't understand the complexity of making a car. How the engine works, how the piston works. We don't really understand those things. And we don't have to. All that we are interested in is drive the car. Not really interested in how the engine works. Don't care. The same thing here. We don't really care how these blobs work, how the hashtags work, unless you are really a Git programmer. For a regular user, even for a developer, these commands are more than enough. Git is essentially a developer's tool. We don't develop too much. As a DevOps admin or a cloud engineer, you work very less on development. Probably you're working on some scripts, bash scripts or Python scripts, or you're working on some Ansible playbooks. That's all you're doing. Beyond that, you don't do much coding, right? So these commands are too much for us, right? So basically you are an intermediate user with these commands, if not advanced. This is what is internally happening.
So these will store in Git repository.
Yep, here.
But we are
In this direction.
files on our command prompt.
Yeah. When you say Git, when you tell Git to init, it creates a directory. When you say Git add, it stores somewhere in some file. Index is a file again.
How to check again?
You can
How to check again that whether files are storing on?
you can get into this cd into .git, do a cat on all the files. You will see the content, but we don't understand how Git actually handles it. But you can see that. You can cd into .git and do a cat on all the files. You will see some of the content that you are doing here in some of the files here. You can do that. Any questions? So you have to understand Git local. Everything on Git happens locally. GitHub is a remote repository. Now, what's the difference between Git and GitHub? That's a question that everybody is confused about. What's the difference between Git and GitHub? Try it. GitHub is just a server where you store the stuff. What stuff you store? You store a Git repository. That's all you do. That's all you do. Nothing much. Now, just like GitHub, there are other websites also which allow you to store your Git repositories. The next two popular ones are gitlab.com, bitbucket.com. These are the three most popular ones, remote Git repositories. You can go to each of these websites and create a free repository, and you can push your local repositories into a remote one. The document that you are given is on the Git repository. Yeah, I think this laptop is down. I'll show it to you tomorrow. So the gitlab.com slash blob 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 that you are accessing the URL from, that is a remote repository I have created.
How much storage they use for React?
About 5 GB, I think. 5 GB they give. That's too much, kind of. If you are writing 5 GB of code, then you are a prolific writer. Writing, pure writing. The problem with free account is it does not allow any access control. Means, for example, you cannot allow a person to only read your repository. In our case, let's say the whole repository has to be made public. I cannot allow only you people to be able to read it. The version controlling is then the free accounts. If you want such kind of control, you have to go for the support. The version, the pro version, the enterprise version, where allows that's when if you are in an organization, you take an enterprise version of GitHub. There you add all the team members to your repository. So only those team members can see the code and push the code into the repository. That's the main area where they make money. For a regular user, you just push the code, individuals kind of. You can create an account and try it out.
Git Clone, sir?
Yeah, that's correct. Let's say you have a directory here. You are starting everything fresh. You don't have anything at all. You joined a project new, all right? You brought in your laptop. There is nothing on your code. You did not write anything at. There is a project going on. Your team members have written some code. Now from today onwards, you are starting to check the code, modify the code, add your own code to it. Which means you have to pull everything into your local repository. Now the easiest way is to clone it. Git clone the whole thing, the URL of remote repo. It basically is a pull command. So you are doing a clone. You're just making a copy of everything into your local repository. So it should be here, git clone. Git clone the remote URL. It brings everything in here. It also does git init automatically. It makes the directory wherever you are cloning into a Git repository, which means it creates all the Git and everything, .git directory and everything. Then you can start to add your own stuff. Then this whole local repository thing gets created inside this. And once you're done, you can push it to your remote if you have permission. Now pushing to the remote obviously requires that you have permissions to push it. Now the Git clone is usually for public repositories. You have a public repository, the user has given you access, it's publicly accessible. You want to bring it to your own laptop, you just do a Git clone.
You have to install this tool.
Yep, Git has to be installed. It can be installed both on Windows and on Linux. You will have that task in your workshop. It's a simple installation. You have to install. Nowadays, Linux systems usually come with default Git installation. You don't usually install it in a separate way. Windows hasn't included. Probably next Windows version will include the Git. Just like Explorer, Internet Explorer is automatically included, right? The same way they're going to include Git also next. But right now, we have to install Git. So Git installation is, I think this is the first task in your workshop. All right, any questions? We will be using Git also throughout all our sessions. Now Git is so kind of available everywhere. Everybody uses Git. Instead of the curl and wget, Git is more popular now. The Git Clone and Git Pull have replaced your curl and wget. Earlier, when you have a URL, you want to download it, you used to use a curl. But now, because everything is stored on Git, you usually pull it from Git if it is a regular code. All right, any questions?
So the second link is about the Ubuntu server on Katakoda. So we will be installing the Git on Katakoda sessions and so let me share my screen. So this is the URL on which it is a bare instance of Ubuntu. I'm installing Git on this server. Okay. So after executing the task number 1, that is installing the Git, please open the GitHub. So after installing the Git using this command, just open this URL. I will be just opening it in new tab and try to create an account here. So that is regarding the task number 3. Once this is done, then we will be able to do the next step. The task 5 or a task 6, we can do that. So after installing Git on this Katakoda, this session, try to open this GitHub and create your own account in GitHub. Then we'll move on. See, it is like a general account. General account in the sense it's like a Facebook account or an AWS account, whatever it might be. It's like a general social media networking account. You can create directly using your username, password, and first name, last name. Then your GitHub account will be created. I will just post the URL. You do have. Open this URL and create your own GitHub account.
Pull request from Tomcat to Git. Fair enough. Let's see what is a pull request first. Let's see what is a pull request. I think we did not discuss it in depth. You have a local repository. What are the three areas of local repository? Your work directory, index, and local repo, the tree. All right. This is where all your commits are. You do anything and you bundle it, compress it, and you commit, isn't it? Now, once you commit it, your remote repository like GitHub is available online. You want to push the code here, isn't it? But this code or this repository, a lot of people are expected to push code to. So even this has a branch called main or master. But what normally happens is this main branch is locked, kind of. It's not possible for everybody to push code directly into it. If we allow that, what happens is it could happen that some random code got into this main branch and it will destroy all the code available there. So what normally happens is instead of your main branch, you have another branch here, right? This is usually called a feature branch. Let's say you are developing feature A. Now, when you're developing feature A, what you do is you don't push to the main branch. You will do a push to the another branch. Let's call it feature 1. Same feature or feature A. For that, your command is going to be git push on the origin. What's the branch name? Not main. It is feature A. That is the branch name. So where is your code now? Not on the main branch, but on the feature A branch. Now you need to tell somebody to pull this code into the main branch. This code has to be merged with this, the original code. Now to do that, or the software way of doing it is, you as a developer will raise what is called a pull request to the owner of the main branch. Now each branch or the main branch can be controlled by user IDs on GitHub. GitHub allows each branch to be controlled by an individual. So if you are a team of 10 members, let's say, only 2 or 3 members will have direct access to the main branch. What they normally do is, anybody in the team can push the code to a branch and that person will raise a pull request, popularly known as a PR. The meaning of pull request, the English is a single request, simple English. You're asking, pull my code into main branch. You're asking the owner of the branch, pull my code into main branch. So then what happens is, the owner of this branch usually verifies the code on your branch, and if everything is good, they will merge it into main branch. So what we are asking through a pull request, you are asking your code to be merged into the main branch. So every time we develop a code, instead of directly pushing into the main repository, main branch, you always push it to another branch and raise a pull request. And the owner of the main branch reviews your pull request. If everything is okay, they will merge your code into the main branch. Once this code is merged into the main branch, we may choose to delete this branch because we don't need that branch anymore. That decision will be taken by the person who is merging your code from your feature branch into this. All right? Now you understand what is a pull request and what happens during a pull request. Now let's start your question.
I'm getting problem in this one, pulling and pushing of these codes to these.
What's the problem? What is the problem?
That the petal not something.
That's not the error, the way you explain an error.
Actually, I forgot to say.
Look at the screenshot, tell me what the error is, or try to redo it. Okay, roughly where do you think is the problem? What were you doing when you encountered that problem? You're trying to pull the code or you're trying to push the code? When you're pushing the code, what's the error? Your steps are like this. Git add, is that successful? Then your next step is git commit -m message. Probably this is where you got an error. The error is basically you don't have user.name and user.email. Is that error? There is no error. You have set these two things using git config. Very good. Then your commit is successful. If this is not an error, then your commit is successful. This is the only problem because everything you are doing it locally still. The only problem you can encounter here is this is not set. That's what it complains sometimes. Sometimes, all right? Only sometimes. It's not a mandatory thing. GitHub does not mandate that it should exist. Even blank can be sent. So, or you can obviously set up these two parameters, git config. You can set it up globally, means for all the directories that you're working, all the repositories you're working, or if you don't give this, it is per repository. You set up two things, your name and your email. You can set up anything. It's just information. It's not authentication. It's just information. This information goes into the remote when you are pushing the code, so that the person who is viewing your code can get some better information into it. Which user is pushing the code? What's the email ID of the person who is pushing the code? All right. Once you set it up, your commit will be successful, which means your code is on the local repo. Now you want to push this code to remote repo. Now at this point, your remote repo should already exist. Should already exist. Now the easiest way to do this thing is, obviously you have to go to github.com and create that account, then create a repository. You have to do it all on browser. You can do it from command prompt also, but this is a much faster, easier way for you at this point of time. So you created a GitHub account, you created a new repository. Now when you created a new repository, usually you will get your URL like this, github.com/username/reponame.git. That's usual URL. All right. Now what you have to do is, this, whatever is the content, you need to pull it first to the local repository. Then what happens? Now here, let's say you run this one, git pull remote repository, or git clone it first. The easiest way is git clone this URL, github.com/username/reponame.git. Now when you do a clone, what happens is Git sets up the remote repository to this URL. So what happens now? Remote equal to this thing, right?
Before this step, we should commit the.
Usually this is the first step.
This is executing, sir.
This will execute because you're pulling everything from there. Let's do one thing. What you should do is, ideally, the way workshop is designed is like this. You create that one first, all right? Then you have an empty repository. Then you do a git clone. It will warn you you are empty, you are cloning an empty repository. It's just a warning. We know, yeah, we don't have anything. Now the reason why we clone it is, it sets up the whole structure of Git. This whole structure it sets up by just doing a clone. Otherwise, you have to do the git init, you have to do, which will set up everything. Then you need to add git remote. Git remote, add origin URL, this whole thing. You are manually adding the remote repository in this case. Then you can do a git add, commit, push. This is a general, if you are doing everything from the local server. Or the easier method would be create a repository. Come in please. Come in please. Come in please. Create a repository remotely. So you have everything over there. All right. You have everything over here. You clone this thing here to your local repo. That's okay. You clone an empty repo. Now, when you are cloning, you are essentially setting up two things. One is you are executing git init, because when you created a repository here, it actually initiated the whole structure. It just brings in the whole structure here to the local system. Then you are also adding a remote. Git remote add. There's another command. So what you are doing here is you are telling this directory, the remote is this thing. So this directory knows about the remote, and it also initiated as a Git repository. This structure is ready. Now, normally your workshop is like this. So after you git clone, you add a file like touch abc or something. So you have added a new file, or new code is added to it. Now any code that we add should be added to the index. So that's your git add dot. That's adding to the index. It's coming here. Then after you added, you are doing a git commit with a message -m. Then you are compressing and putting a blob in here. So everything is ready now. Now you do a push, git push origin. Now when you give this origin, you basically, the clone has set your origin over there. If this you did not execute this command, this will fail saying, I don't know what the origin is. Then when you say git push origin, obviously you cannot send it to main because main is low. You can send it to a feature. But in your case, you can actually send it to a main also, because this is your thing, and I think most of your accounts are free accounts. You do not have the mechanism to lock it. Only pro accounts allow you to lock it. All the free accounts or personal accounts, mostly, this feature is not given to free accounts. Only pro account can lock it. So in your case, git push origin main should still work. Clear? How many of you got the errors around here? This one? Yeah, this is one thing that sets up everything. So the easiest way that I normally do is go here, create a repository, clone it, clone the empty one. So on a local system, I have everything ready. Then we start adding files. Even if your files are somewhere else, copy all the files and paste it here. So they are all coming to working directory. Then we add using git add. They come here. Then we commit everything. They compress here. Then push. These are the only 4 commands I use. That's all. You don't have to really do anything else other than these 4 commands. And I think there was another question Mohammed asked yesterday on that Catacoda. Catacoda has multiple IPs. All right. So all the IPs do not work. The reason is the Docker IP that you see with IP-A command, the Docker IP is internal IP. Means it will not work for ping. So what you have to do is the ENP or ENS03 IP is there. That's what you should use. Only one of the IPs will work for ping and curl. Run Docker IP-A if you run it, if you see Docker as the NIC, network interface card, this is not going to work. There's another IP you will see. That IP will work for all our workshops and everything. The Docker IP is internal IP. Let me show it to you. I think you guys have posted it yesterday. Yeah, I think this is a query somebody posted. Mohammed posted it. If you see here, you see there is a Docker 172.18.0.1 that will not work. There is another one above 172.17.0.13 by 16. That is the one that will work always. So for your ping and your curl command, always use the first one. The one that you have with ENS3. You have it on your Slack. All right? That's a common. Sandhya, check with Vasu if you can start by 7:45. Hmm? Okay. Next question. Let's start with all the workshops, Unix or Linux commands. Any questions from anybody? You're able to recollect the commands when they are needed? Some commands probably we have added in the workshop, so you may see once in a while some new command. When you come across such a command, just note it down. If you have questions about that command, ask me and I'll explain it to you. Usually most of the commands we have discussed, but maybe some might have slipped. So Linux commands, everybody good with? Are you able to remember those Linux commands? You should. If somebody accidentally asks you, okay, tell me some 20, 30 Linux commands you should be able to spell them out quickly. Because we practice those things every day. So if you are working, you are actually working 10 hours a day on those Linux commands. We have blocks, right? So let's say network, you have about 4 or 5 commands. IPA, netstat-nap, then IP routes, then those are 4 or 5 commands, or ns lookup, 5 commands. If you are on process, you have ps-ef, stop, hstop, then kill-9. Those are some process-related commands. Files, you have about 4 or 5 categories. To create a file, touch, cat, mkdir, or m-rf, copy-r, move. So it's just categories of files. The moment you recollect the category, there are only 4 or 5 commands in each category. So you should be able to easily recollect about 30 commands, just around, out of your, just a general logical flow kind of. All right. Next, after your Linux, we went on to Git, isn't it? Any questions in Git? Is the workshop actually helping you, or is the trainer who is doing everything and you're keeping quiet? We have no way of knowing you are actually doing or not. We don't really know whether you're doing or not. you can quietly sit here and say, I'm done. So, no, it's a kind of, it's a kind of, becomes useless for the trainer and for me. So you are actually trying everything? You are interacting with the trainer, right? I see only a couple of you sharing your screen, but others are awesome, awfully quiet kind of thing. So everybody doing it? Sure? Okay. You should ask questions. It's okay. Like they share it, they can see your screen. What exactly is the error? He can tell you, how to move forward. And also workshop, because we're trying to get it done by everybody. The pace of the workshop is not really very slow. It's kind of rushing. That's the way we want to keep it, because otherwise we will not be able to finish it by 10 o'clock. Not possible. So it's also important from your part that you try to execute it. And most of the workshop commands you can copy paste and still they'll work. That's how they are designed. Once in a while they'll fail, otherwise they'll work. Everything. The environment is customized, the category, everything is pretty much customized. You won't find any commands failing. Very rarely that happens.
We are getting that error.
Which one?
It's replacing. Not copying exactly. Some comments.
That's a good thing in a way. Then you type it. yeah. Sometimes it slows down a little bit. So maybe in a way.
Comments are getting like that, sir. But what is the error there?
It depends, because it's the category is they are trying to do what usually happens on a Linux regular prompt. They are trying to do it in a browser. So sometimes the regular copy paste other stuff won't work.
I saved history. I write from notepad comments.
Okay. Okay, maybe the integration between browser and the notepad probably is not happened properly. Usually there are such problems if you launch a fresh session, they usually get resolved. But when you launch a fresh session, your old session gets killed, so you can't do that also. Then our only choice is to type the commands.
I tried language, but
Okay. Okay. Any questions in Git?